Hello everyone, my name is Abhishek and welcome back to my channel. Today is the very first episode of Linux Zero to Hero series, and in this episode we will focus on fundamentals of Linux. The main goal of this course is to help everyone master Linux, whether you are from development background, DevOps engineering, or even someone beginner in IT. By following the course, you will be confident about Linux. To make it simple, I have categorized the complete course syllabus into 10 different sections, where each section covers a topic in Linux, and some of these sections might have subtopics as well. Overall, we will complete the end-to-end course in 5 episodes or 5 tutorial classes. Some classes cover a single section, and some classes cover multiple sections. It all depends on the complexity. So, what exactly are we going to learn as part of this course? So we will start with the first section, getting started, where we will learn about the fundamentals of operating system. Then we will learn about Linux operating system, the structure of it, various distributions in Linux, and most importantly, we will cover how to set up a Linux system on your personal machine. A lot of people create cloud instances and they continuously keep watching the cloud instances. They worry about the cloud billing. However, to learn Linux, it is not required. I will show you how to set up Linux system on your machine for absolutely free of cost. Then we will learn about package managers, what exactly are they and what do they do. This is about section 1. In section 2, we will learn about folder structure. By default, when you create a Linux machine, there are a lot of folders that are available on that machine. So what exactly are those folders? These are especially important while troubleshooting a Linux machine. So I'm going to cover all the folders, all the files that are important out of the box on a Linux machine. Then in section 3, we will learn about user management. User management and RBAC are two important advantages of Linux over Windows. So that's why in user management, I'm going to cover how to create users, how to create groups. Additionally, what are the files that are important for user management and group management. In section 4, we will learn about file management. Quite obviously, while learning with or while working with Linux, you will write data into the Linux systems. So you need to know how to create files, how to delete files, in general, how to operate with files. So we will learn various commands that a software engineer use in day-to-day basis while operating with Linux systems. In section 5, we will learn VI shortcuts. So to write data into a Linux system, a popular utility is VI. So we will learn how to use VI editor, what are the different modes in it, and various shortcuts that enhance your experience with VI. Then in section 6, we will learn about file permissions, a very important concept of Linux. So I'll explain you how exactly file permissions in Linux work, and we will also learn how to restrict a user from a file and how to grant access to a user with files. So we will learn a lot of things in section 6. In section 7, we will learn about process management. In a Linux machine, various processes run. So as an engineer, you need to learn how to find out the process, how to kill the process, and how to perform the process management. So again, we will learn about various commands of process management in section 7. In section 8, we will learn about monitoring a Linux system. So when operating with Linux system, just like processes, you deal with a lot of files, you deal with a lot of logs. So everything that is needed to monitor a Linux system, you will learn in section 8. In section 9, I'm going to cover about the Linux networking. Although I made a lot of content on Linux networking, whether it is IPs, CIDR, to AWS networking, Azure networking, in this tutorial, I'm going to cover basic level of Linux networking. That is, as a software engineer, if you want to identify issues with your Linux network, how do you do that? In section 10, we will learn about disk management. So disk management is a common operational task. Adding disks, removing disks, mounting volumes. We will learn all that as part of section 10. As I told you, although there are 10 sections, we will cover everything in just 5 episodes or 5 tutorial classes. All the notes related to Linux Zero to Hero series is uploaded to this GitHub repository, which is called Ultimate Linux Guide. You can find the link to the repository in the description. And as the series progress, if I have to update more documentation, I will keep doing it. So just start the repository, poke it to get continuous updates. Now that we learned about the core syllabus, let's start with section 1. So let's explore the following concept as part of section 1. We will start with absolute basics, that is operating system. Instead of learning what is operating system, let's start with why operating systems. This might take you back to your school where you learned basic computer education. You might have learned the physical component of any computer is what we call as hardware. What is physical component? Combination of CPU, memory, storage, motherboard, and network interfaces. There are two primary actors who wants to interact with the hardware or who wants to interact with a computer. One is the users, that is you and me. Two, software applications. Users want to interact with the hardware, maybe to create files on the computer, folders on the computer, or even to manage the resources of the hardware, maybe to check the status of the CPU. Applications, for example, you're watching this video on YouTube, which is nothing but a software application. And for YouTube to run, it needs CPU, it needs memory, and it also needs some disk space. And all of these are available with the hardware. So both users and application wants to interact with the hardware. However, both of them are not directly capable of interacting with the hardware. If you take applications first, imagine you write a simple Hello World program in Python. You do not write the instructions on how to manage the CPU for this program. You do not write the instructions on how to get memory allocated for this program. So obviously your application cannot deal with the hardware resources because you have not written the code. Similarly, as users, you cannot directly interact with the physical component. You at least need a graphical user interface or command line interface. And both of them are not provided by the hardware. Because of these reasons, both of these actors cannot interact with the hardware, but a intermediate layer, which is called as operating system, can help them. What is operating system? Operating system is a special software program that knows how to use the hardware. So it can basically perform process management, memory management, device management, and even network management. Because application is also a software program, it can talk to the operating system, which is a software layer, and this operating system, depending on the program, It allocates the CPU, it allocates the memory, and required hardware resources. This is how your programs actually interact with the hardware, or software interact with the hardware through operating system. Now you might wonder, okay, but as users, we cannot still interact with the operating systems. Yes, but what operating systems do, especially for the users, they provide an additional layer, which is nothing but CLI or GUI. If you take Windows operating system, it provides a rich UI, whereas if you take Linux operating system, it provides rich CLI. Anyways, through this layer, users interact with operating system and in turn talk to the hardware resources. Now, if we look at the definition of operating system is an intermediate software layer that acts as a bridge between software and hardware, or acts as a bridge between user and hardware. It performs process management, memory management, device management, and network management. You can find this definition in the GitHub repository as well, where I explained more about process management, memory management, and other things that your Linux operating system can do. Now, saying this, Linux is not the only operating system. There are other operating systems like Windows, Mac OS, and multiple other. However, these are the three popular operating systems in the market. At this point of time, it's worth understanding the history of operating systems. So let's take a sneak peek. In 1960s, Unix is the first operating system that was developed. Before Unix, it was very difficult for the application developers. Although the application developers were very, very less, still it was difficult for them to interact with the hardware. They used to do some advanced programming or typical hardware level coding to get their applications interact with the hardware. And Unix solved this problem. So it became very popular in no time. And looking at the success of Unix, in 1970s, another operating system was released, which is Minix. Minix was kind of developed on top of Unix. Unix was open source, but Minix is not completely open source. It was partially open sourced. In 1980s, there was a revolution in the space of operating systems when Microsoft released their operating system, which is Windows. And Microsoft's operating system, unlike the previous operating systems, had a rich graphical user interface. Now, this rich graphical user interface made communication to the users with the hardware super simple. They don't even need to know the commands, which was required with Unix as well as Minix. In 1990s, because Windows was very successful, Minix was also very successful. However, they both were kind of proprietary. They need some license for the developers to use or companies to use very specifically. That's where in 1990s, a person called Linus worked on the development of Linux kernel, and this was the first popular open source operating system. Although Unix was also open source operating system, this was competitive with Windows, or in many of the parameters, it also surpassed Windows. So Linux became the new popular choice for the developers and also for the companies. Even today, that is in 2025, if you look at Linux versus Windows, 90% of the production workloads today, whether it is the software running on your mobiles or the applications that you're using deployed on the servers, most of them, 90% of them use Linux operating system. It's not because Linux is free. Many people think because Linux is free, companies go for using Linux. This is some part true. However, the major part is that Linux is open source. Now, because Linux is open source, it's not backed by a single company, but it is backed by a community of developers. So these developers, they are huge in number, and due to the active contributions, they ensure Linux is always secure. So the major reason why companies go for Linux over Windows is that Linux is open source, it is free, and it is super secure compared to other operating systems. And this combination is very rare for companies. Something that they get for free and very secure. So companies grab that opportunity. That's why Linux became a very popular operating system. So let's do a very quick recap at this point of time. We learned what is operating system. Operating system is an intermediate software layer between your software applications or users and the hardware. It is the heart of your computer, and there are multiple operating systems such as Windows, Linux, and Mac OS. We also looked at the history of the operating system and learned that Windows is the popular choice when compared to, Linux is the popular choice when compared to Windows. Now that we have learned the fundamentals of Linux or operating system, let's try to understand what is the structure of Linux. So the main component of Linux operating system is called as Linux kernel. So what does Linux kernel do? Everything that we discussed till now. So the interaction with hardware such as process management, memory management, disk management, and network management is handled through the Linux kernel. So this is basically like the engine of the car, which is doing the heavy lifting. On top of the Linux kernel, there are some layers like system libraries or some system packages. And on top of that, there is a command line interface. Or at times, Linux also provide graphical user interface. That's it. This is Linux operating system. You can also find that here. If you go to the Linux structure, you will notice the physical component is hardware. On top of that, you have something called as Linux kernel, which takes care of process management, memory management, file system management, and network management. To make the Linux operating system rich, it also comes with system utilities such as basic commands out of the box and some basic libraries out of the box. So this ensures that Linux is rich in features and also Linux is secure. On top of that, there is binaries such as CLI or graphical user interface. Usually when it comes to Linux, it is CLI. That's it. So these four things is basically what we call as Linux operating system. And the most important component of Linux operating system is Linux kernel, right? Abhishek, is it possible to ship Linux operating systems without these things? You can still do it today because kernel is the one which is taking care of the major responsibility. So you can actually remove most of these things and even ship a Linux operating system. But this will help the users. That's why you have system utilities, libraries, and shell. Shell is mandatory. Without CLI, users cannot interact with the hardware. Perfect. So now we understood the operating system of Linux. We learned the components of Linux. Now let's see what exactly is this Linux distributions. We keep hearing about Ubuntu, Red Hat, Fedora, Debian, Alpine. What exactly are all of these things? It's a very easy concept. As I told you, Linux is open source. So the people, Linus and other contributors, they have developed Linux and they made it open source. So when it is open source, you are free to download the code and you can add more features to it or remove certain features to it and ship as a product. That is where companies like Canonical saw the opportunity. What they do, even today, Canonical as a company, they take the copy of the open source Linux, they add some more features, they add more wrappers on top of Linux operating system and provide that as Ubuntu Linux distribution. There is another company called Red Hat, which also does the same thing. So they take the copy of the Linux operating system code, they add more wrappers to it, or they add more functionalities to it, and provide that as Red Hat operating system. Similarly, Debian, Alpine, Fedora, all of them do the same thing. So basically, they all have their origins common, but they add more wrappers, they add more commands, or they add more features and distribute them as new products, right? That's why if you have a program, or let's say you have a shell script that is running on Ubuntu, most likely it also works on Red Hat because underlying system libraries are common, underlying system packages are common. So they all work. Like when you write a shell script, it works on most of the Linux distributions. But the same thing doesn't work on Windows because it's a complete different operating system. Perfect. So which one is popular? Ubuntu is a very popular operating system. And if you want to get started, I would highly recommend Ubuntu as a operating system because it's very easy to use. It also comes with most of the required system packages and libraries. So for beginners, it's hassle free. So this is what we call as Linux distributions. Now the next thing is how do we set up Linux? Okay, Abhishek, I understood what is operating system. I learned about the history of operating systems. I learned about the structure of Linux. I know what is Linux distributions and Ubuntu is the popular distribution. Now tell me, how can I install Ubuntu on my machine? Let's say you're using Windows machine. One simple thing that you can do is install WSL. So WSL stands for Windows Subsystem for Linux. It's very simple. Just go to your command prompt or PowerShell in your Windows and run the command WSL hyphen install. So WSL package is available out of the box on your Windows machine. Just go to your PowerShell and run this command. When you run WSL hyphen install, it creates a Linux-like environment on your Windows machine. It does not create a virtual machine, but it creates a Linux-like environment on your Windows machine. And once this is done, just restart your machine or reboot your machine and go to your command prompt and run WSL again. When you do this, you have Ubuntu running and you can access Ubuntu machine on your Windows. It's as simple as that. Many people don't use this option and they go for EC2 instances on AWS or they go for virtual machines on Azure. They constantly try to stop the instances, start the instances just to learn Linux. Trust me, to learn Linux, whatever we are going to do in the 10 sections, you don't need an EC2 instance. You can just learn that on your personal machine using WSL. Abhishek, for some reason, I cannot run WSL on my machine. Is there any other alternative? Definitely yes. You can use Docker. If you don't know what is container or what is Docker as a container platform, you don't have to worry. Just run the command that I'm going to share. So if you go to setup.md, you will find this Docker command, which is a sophisticated command that I have designed. So I've added all the properties so that your Docker container runs as a Linux machine on either your Windows or Mac OS laptops. For example, I'll just copy this. I'm using Mac OS. So let me clear my screen and I can just copy this. I can just change the name of the container. Let me just call it as Ubuntu demo container. And when I run this, okay, so there is the path difference. Basically, this command is designed for Windows out of the box. I can just change the source folder from C to /tmp, right? Just make sure you have this folder on your machine. On the GitHub documentation, so the path is C drive followed by Ubuntu data and the target path that is within the container, it's data. So you don't have to modify this. You just have to make sure this folder exists on your Windows machine. If it does not exist, go to your C drive and create a folder called Ubuntu data. I can do the same thing. What I'll do is I will go to /tmp directory and within the /tmp, I will create a folder called Ubuntu data. Okay, so I created this temporary directory. Now I can see that Ubuntu data exists. So I'll just go back. CD. So I'm just randomly going to my home directory and I will run this Docker command by just modifying, right? I'll just change the C Ubuntu data to /tmp Ubuntu data. Okay, it says the container name exists. I will just change the name of the container to Ubuntu container demo. Perfect. You can see that the container is running. Now, what is the next step that you need to do? Just exec to the container. How you can do that? Copy and run the command docker exec -it followed by the ID of the container and /bin/bash. That's it. You have a Linux environment running on your macOS or even Windows container. I'll just repeat this because some people might be new to containers. So I've taken my terminal. If you're on Windows, you can take your command prompt or you can take something called git bash. Go to our documentation, take this Docker command. I have designed this in such a way you get the feel of Linux machine running on your Windows or Mac OS. Just copy this command and the first thing that you make sure is you provide the name of the container, something of your choice. For example, I will call it as Ubuntu Linux Learning. Everything remains same except this particular source folder. So you just need to make sure this folder is something that exists on your computer. Why? We are creating a container which is a small Linux system just for people who don't understand Docker or containers. And we are just providing it the storage from our local computer. So by default, that Linux computer or a small computer does not have the storage. I'm just binding my local location, which is slash tmp slash ubuntu data to slash data folder of that computer. Now, whatever storage or whatever files are available in this particular location can be accessible through the container as well. So if this particular location runs out of storage, your container also runs out of the storage. I will get a container ID. So I just need to copy that container ID and run docker exec -it followed by a long container ID that you would get, followed by /bin/bash. Now that is exactly what I've done some time back. I ran this command and now I'm inside Ubuntu Docker container, right? Initially, I created this container and using exec, I went into the container. Now you can run any Linux command here. You can explore the folders and you can typically do what I am going to explain you in the next sections. You can perform process management on it. You can write shell scripts in it. You can learn different files and folders, anything that you want to do with a Linux environment. So it is as simple as that. Either go for WSL or use the Docker container to simulate Linux environment on your laptop. If both of these don't work, which is extremely rare case, only then go ahead to your cloud platform and create a cloud instance. Once you create a cloud instance, you can access it and start learning Linux. But to avoid costing and to make it easy, I would recommend these approaches. Now, finally, what is package manager, right? So the last topic for today's section is understanding package managers. If you go back, so I have a Linux environment where I'm using Ubuntu. Now, how do I install packages on it? Let's say I want to install Python. If you're using Windows machine, you can go to the internet, download packages. But when I am on Linux, how to install packages? Of course, there are commands to install the packages, but what these Linux distributions do. Like I told you, Linux distributions take the open source code and they add more libraries. One such thing the Linux distributions do is they add package managers. Now, what are these package managers? Package managers help you deploy or install a dependency, something like Python. It helps you upgrade to the new version of the package, delete the version of the package, or even maintain the packages, right? The best example is Python, Java. Using package managers, you can install Python, you can install Java, you can remove Java from your Linux machine, upgrade Java, or continuously maintain the versions of Java. When you're using Ubuntu, the package manager is apt. So apt is installed out of the box. So you can just run apt list. For example, it shows list of packages that are available on this machine. So when you create a Linux machine, already all these packages are installed. For example, you run Python. If it is already available, or you run bash. So this command got executed because bash is a package that is already installed when you created the Linux machine, right? Similarly, when you run apt again, you learned what is apt list command. It lists all the packages. Similarly, you can run apt search to search for a particular version of the package, or you can do apt install. Abhishek, what is apt install. So when I do apt install, let's say Python 3. So what it does is it goes to a centralized location. So these package managers download and cache some dependencies, commonly used dependencies, and they store them at a centralized location. For example, Ubuntu stores in archive.ubuntu.com, I believe. So whenever you run apt install Python 3, it goes to that location and downloads Python 3 from that trusted location. Of course, there are some packages which are not available with the package manager. Then you need to know curl command or wget command, which you will learn in the future classes. So that is the use case of apt. First time when you install, you need to run apt update. So it is required because whenever you are installing a Linux virtual machine, this kernel might be packaged sometime back. So it is important to update all the packages on your machine. Only then you can run apt install Python, for example, right? So it says the package is basically Python 3. And if I run apt install Python 3, it is installed on my machine. So this is how the package managers work. It also tells us that, see, it is trying to look for this particular location, ports.ubuntu.com. From this location, it is trying to download Python 3. Perfect. So it downloaded and now I have Python 3 on my machine. So this is the use case of package managers. So what we have learned today, we have learned the fundamentals of Linux, where we learned what is a Linux kernel, what are the responsibilities of it. Similarly, what is Linux operating system? We learned about the comparison of Linux with Windows. We learned various Linux distributions, the setup of Linux using WSL as well as Docker container. Finally, we learned about Linux package managers. This is the most important point. Going ahead, please try to use WSL or the Docker container that I share to use. In case if this doesn't work for you, do let me know in the comment section. I will definitely respond back to your comment and make sure it works for you. Or even you can join our Discord server. Links will be in the description. So this is the first section. I try to keep it simple. From the next section, it is going to be interesting, where we are going to learn a lot of new things. See you all. Take care.